Hey everyone, welcome back to another lesson. Today we're going to start talking about, well, you know what, I'm not going to spoil it. Well, I guess the title of this video is going to spoil it, but what we're going to do is we're going to actually complete the square on the general format of a quadratic. We're going to solve for x here. It sounds kind of weird, but if you think about it, if I do solve for x, then I actually have some sort of formula that I could use for almost every quadratic. So to solve this, I'm going to use complete the square. Full disclosure, yeah, this is going to be a little bit different than what other people have used to solve. Is it going to be more steps? Maybe. But there's a reason why I'm solving it in this method, and we'll talk about that more in some future lessons and videos. But let's just go ahead and get started. So this is going to be part one. We're going to actually solve this guy first, and then I got two examples I want to try out with you. Okay? So let's get started. So right now, what I'm going to do is I'm going to group the first two terms together, okay? Plus c, the constant, we're going to leave it right on out. Now, because there's a term in front of this x squared, the quadratic, I have to factor that out, right? Typically, people will divide everything by a and then go forward, but I'm not in this case. I'm only going to factor a out of these terms right now. So I have x squared plus b over ax, and then plus c is on the outside equals 0. Now, just like the previous videos, I want to come up with a number, some value, that when I put it here, it makes this guy a perfect square trinomial, because this is what I need to factor. Now, if you're not sure what to do, then, well, let's do something off to the side. Let's doodle for a little bit, okay? So, let's do that. Pretty much what was the pattern? Take half of this guy, so b over a, we're going to take half of it. So we've got b over 2a, and then you're going to square it. So then we get b squared over 4a squared. That number is going to make this a perfect square trinomial. So it's going to be b squared over 4a and then squared. Okay? Now, that's going to enable us to finally factor this guy. Okay? So let's go ahead and do that. Now, if you remember from some practice problems that half of this guy is the factors. So this is just going to be b over 2a. I'm not done yet. Remember, this equation, I changed it. I added something to it. So if I were to simplify this, I don't get the original no more. I don't want that to happen. So typically, what did we do? We took this number and we subtracted it on the outside. So that way everything's in balance. Well, I factored an a out. So this truly isn't this number. It's this number times a. That's what I added to this equation. So this is going to be, be ab squared over 4a squared. I'm going to put that over 1 right now. Does that make sense? So it's a times this value. That's what I want to subtract out. Looks ugly right now, doesn't it? But that's okay. We're going to keep working with it. Just continue following the steps for completing the square. Now, back over here. Let's doodle a little bit. I want to combine these. A common denominator would be what? 4a squared? So the first fraction, I'm not going to, well, I guess that might be the second fraction. But I'm not changing this one. Over here, I'm going to change this guy, right? So I'm going to multiply top and bottom by 4a squared. So I have 4a squared c minus ab squared divided by 4a squared. What do you think? We're okay with that? Instead of separating into two separate fractions, I just combined them, and that's your common denominator. I'm going to do one more thing. Notice how there's a's in each and every one of these. I'm going to go ahead and factor an a out. When I do that, when I factor the a out, this is gone, so I have one a left there. This a is gone, and one of those a's are gone. Okay? That's just simplified things just a little bit. I'm going to go ahead and rewrite it. So this is what I'm left with. Plus 4ac minus b squared over 4a. Oh, equals 0. Sorry, we are solving this. Okay, so far, man, this is still looking kind of ugly, but let's continue. I'm going to take this fraction over to the other side. So a times x plus b over 2a squared equals, now when I subtract this, the signs in the numerator are going to change. So I get negative 4ac plus b squared over 4a. I'm getting closer. Now, to get this by itself, I got to divide a to the other side. Now, when I divide a to the other side, it's like you're multiplying by the reciprocal, right? So let me just put that right here. So these would cancel, and then over here, if I multiply by the reciprocal, notice the denominator is going to be 4a squared. So x plus b over 2a, quantity squared, would equal negative 4ac plus b squared over 4a squared. We're close. We are so very close to the end of this thing. So just hang on. I got to erase all my math doodles over here. Okay? Those are gone. Doesn't work no more. I'm going to take the square root to both sides. So square root on this side, square root on that side. So on the left-hand side, I get x plus b over 2a, okay, equals. Now, in the numerator, I'm going to switch some things around. I'm going to make b squared first and then 4ac on the other side. So it's going to be the square root of b squared minus 4ac over. Now, here's the interesting part. I'm going to go ahead and include it right now. If I take the square root of the denominator, that will come out nice. Okay? Square root of 4 is 2. The square root of a squared is just a. So the bottom becomes 2a. I think this is where some people might be saying, man, this guy is doing it so different, and it makes no sense. He's making it more complicated. This is just another method, okay? And like I said, I think this is going to work well when we talk about vertex form and transformations in the future. So just bear with me a little bit. Now I'm going to subtract this to the other side. Now remember, because we took a square root, that's a positive negative over there. So here we go. X equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. Now, because these have the same denominator, I'm going to combine them. So it'll be negative b plus or minus the square root of b squared minus 4ac over 2a. And boom. What do you think? Is that a mic drop moment like that? So we just came up with a formula of what x is. If I know in my quadratic the a, b, and c values and plug them into here, I can figure out the roots for a quadratic equation, whether they're real or imaginary. And there it is. It's really cool. What do you think? Questions? Yeah, it's a little bit of work to get to that point, but still it is doable. Okay, it really is. We call this guy, and this is already the title of the video. I had to pick my marker up. Okay, this is the quadratic formula. Something that you probably encountered in your middle school years, but maybe you didn't derive it yet. Now you know where this comes from. Okay, completing the square helped us figure this guy out. Oh, that's so cool. All right. So we're going to do 2 examples right now of using this quadratic formula, and that'll be it for part 1. Part 2, we'll talk about what's called the discriminant. Okay? So here we go. All right. So example 1. And I'm going to leave this off to the side. That's going to be my little reference so you can see. We have x squared minus 8x equals 33. So my first step is to make it equal to 0. So that 33, I'm going to bring it to the other side. X squared minus 8x, minus 33 equals 0. Now, what I'm going to do is identify what my a, b, and c values are. My a value is always in front of the quadratic term, and that's just a 1. Even though the 1's not there, we always assume that there is a 1. My b value is a negative 8. It's always in front of my linear term. And then my c value is the constant at the very end, which would be negative 33. Okay? Now, what I'm going to do is I'm going to substitute these values into this formula. Be careful of the negatives. That's a huge thing that could really mess this entire process up. And I'm going to be relying on you to help me through this, okay? If I miss a negative, you got to scream at your computer. Say, hey, you missed something, okay? I'll hear it. Trust me. I think I have a way of hearing you. So we have negative b. Now, since b is already negative, it's going to become a positive 8. Okay, plus or minus the square root. Okay, b squared would be negative 8 squared. Minus 4. My a value is 1. My c value is negative 33. All over 2 times my a value, which is a 1. Now, if you worked with this formula before, this is probably really familiar. A lot of nostalgia happening, probably. If this is your first time encountering the formula, you're probably thinking, that's a lot, okay? And it is at first. The more you practice it, the easier it does become. Now, when I simplify this, I simplify what's underneath the radical first, okay? That's what I want to do. So it's going to be 64, that's negative 8 squared, okay? Now, 4 times 1 times negative 33, already it's negative 4, I should have said. Okay, that's going to be, let me try again. That's going to give me a positive 132. Divided by 2. I'm really hoping you're not listening to the conversation that's happening outside my room right now because they're being very loud. I hate that. Okay, now we're going to go ahead and simplify a little bit further. Okay, so we're going to have 8 plus or minus. Now, when I add these two together, I get the square root of 196 divided by 2. Okay? This is a perfect square. It does reduce down. Okay? In fact, it reduces down to 14. So the 8 plus or minus 14 divided by 2. Okay? See how I kind of simplified everything? I started here under the square root, and then I kind of worked my way down. All right? So now we have 2 answers that we can have. And can you see? Yeah, the camera can see it. So for the first one, it'd be 8 plus 14. Okay, 8 plus 14 divided by 2. So for the first one, we're going to get what? 11 for that guy? Be 22 divided by 2. And the last step would be 8 minus 14, which is negative 6, divided by 2 gives me a negative 3. There's my final answer for that guy. Okay? What do you think? Questions, thoughts, concerns, dilemmas? I don't think I forgot a negative. I didn't hear you. So I'm counting on you to make sure that's correct. Okay? I'm going to go ahead and put one more example up here. Oh. It's nice to have multiple whiteboards. Okay, last one. Okay. We have here, in fact, let's do, do I have one that's imaginary, I wonder? Yeah, I do. Okay. X squared plus 13 equals 6x. Okay, let's do one that has some imaginary roots, just so you have some example that works with them. And we're on the 14-minute margin for this video, so I think we can do this with a good amount of time. I'm going to subtract 6x over, and I'm going to write it in a proper quadratic form. Okay, so that means quadratic term, linear, and the constant equals 0. Write down my values. A is going to be a 1, B is negative 6, and then C is going to be a 13. Using the formula over here, I'm going to substitute. X equals positive 6 because we're taking the opposite of B, plus or minus the square root of B squared, which is negative 6 squared, minus 4 times my A times my C value, divided by 2 times the A value, which is 1. See how I put parentheses around each little thing? That's just how I do it. To me, it's nice to see that so you can see what you're substituting. Plus, if you have negative numbers, I think it really brings it out. That negative number makes it easier. Okay, so I have 6 plus or minus, and my first step is to simplify what's under the radical. Okay, so let's go ahead and do that. So for this guy, I get 36, right? Minus 4 times 1 times 13. Okay, so let's see, 4 times 13, what would that give me there? What, 54 minus 36? Okay, so 54 minus the 36 would give me, I think, 16. But it's going to be a negative 16. Oh. Sorry, the square root was a little bit too long. Now that's telling me that I'm going to have some imaginary roots. And remember what that means. Want to draw? So that's telling me that, and this is not the correct drawing of it, but just for an example, that means that I don't have any real numbers. There's no x-intercepts for this graph, okay? So that's pretty good that I know what that is ahead of time, which means that the square root, what's underneath it, is probably going to determine how many answers I have, huh? Keep that in mind. That's going to be for part 2. Let's continue. So I have 6 plus or minus. Now, the square root of 16 is 4, right? And the square root of negative 1 is I. So that's going to be 4i divided by 2. I have 2 different equations here. I have 6 plus 4i divided by 2 as one of my possible answers. And I have 6 minus 4i divided by 2. Now, here's what I'm going to do. And I apologize for this ahead of time. I'm going to erase this real quick. I'm going to factor a 2 out of everything, okay? So if I do that, let's change this up a little bit. So if I factor a 2 out of 6, I get 3 plus or minus. A 2 out of 4 gives me a 2. And then a 2 out of 2 just gives me a 1, okay? So now I'm going to simplify this even further. So my x value could be 3 plus or minus 2i. I don't need the fraction no more. So those are my 2 roots for this guy. That's it. And that verifies because we said that the graph is more than likely not hitting the x-axis. Here's what you can do. If you remember this, you could take your roots. Like this, okay? You could take your roots, multiply them out, okay? And what? See if you get the original quadratic? You should. I hope you do. And in fact, I did this wrong. It should be the opposite. So negative, positive. There we go. Now if you multiply those together, we should get something similar to the original quadratic. But don't have to do that. But it's kind of cool that you could. Okay? All right. So that's it. 2 examples. One that has some real numbers, one that has some complex numbers. If the square root was 0, then I think we just have one solution, right? That's the parabola resting on the x-axis. Okay? Part 2 will be coming later on. Until next time, guys, have a good day. I'll see you all in the next lesson video.